This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Hello and welcome back to another lecture of construction history. In this one we'll continue to talk about skeletons and steel skeletons and how steel skeletons found some complementary techniques and materials, and in particular terracotta, particularly in the first part of the 1900s. So we will still start back from Chicago. We saw before how Chicago has contributed with New York as well and other places in the United States to develop what we often refer as the skyscraper. But more importantly, from our point of view, the experiments of Chicago in the late 1800s are more significant because they represent the evolution of the skeleton structures, and particularly the steel structures that are still used today with some significant modifications and adaptation to the present times. So we'll start in Chicago, but then we'll see how that model wasn't an isolated case, and not only was very influential in North America, but it also became very important for Australia, particularly in the first half of the 1900s. So let me go back to this building, the Reliance building. We spoke about it. We saw how it was probably the first, or certainly one of the very first buildings that had a comprehensive approach towards the use of a skeleton structure. A building that was supported structurally primarily and almost exclusively using steel, and that used masonry only on one of the side boundary walls for fireproofing purposes. The building was also characteristic because it had a relatively lightweight facade, unlike some of the many other precedents of the Chicago School. The external walls had no load-bearing capacity, whether it was to support themselves, but let alone to support other steel members. And the facade was completed with these beautiful terracotta tiles, enamel terracotta, so that they were glazed to have a more long-lasting performance. You can see here in these nice close-up pictures how some of them have withstood the test of time. Certainly some of them are cracked, particularly those ones in the middle of this bow window, but they still perform well. They do still their job in an excellent way. And you can see closely in this view how plate glass is combined with terracotta all around. All the openings have been clad and with spandrels, but also with these smaller mullions that are very slim and cover the steel frames, also for the windows. Now, terracotta is the complementary material of the steel frame structure, and it is particularly important because it had a double function. Yes, it had an external function that you can see also here in the Fisher building, but the function was to complete the envelope, but also to put some ornament on these buildings. And very often there is a bit of a simplification in the idea that Chicago School somehow anticipated the modern movement. The reality is that the buildings of Chicago of the late 1800s, and those in New York as well, they were far from being modern buildings in an aesthetic sense. They were highly decorated. Yes, they were modern in their technologies, but they were still using ornament as a characteristic of, or as an integral part of architecture of those days. And you can see again in terracotta being used extensively to cover up the whole entire envelope of the Fisher building too. And you can see how it's a combination again of spandrels and mullion covers as well. If you look closer at the Fisher building, particularly at the top, in the attic of the tower, you can see how there is quite an indulgence in decoration. Not only you have floral patterns, but that suddenly you start to see a representation of animals like eagles or or Gothic arches, or they are reminiscent of Venice. And so this is ultimately an eclectic approach to architecture that was really part of the function of the buildings in those days, part of the aesthetics and part of the art as well of the architect's contribution to the design of these buildings. And if you look closely, you even find there's a bit of tongue-in-cheek very often. This is the Fisher building. In this case, the architects even incorporated some crabs to remind or to play, or a fish here, monster, in this way, to somehow play a bit with the name of the building. There's even another example in Chicago that is quite obvious, and that reinforces this idea that the modernity was not still there in an aesthetic way, particularly in the facades. Now, this is a building that still stands, of course, today, but it is a building, one of the very earliest buildings that also had the steel skeleton structure, like the Fisher and the Reliance, possibly. Some argue probably the most, some say the oldest, some say, certainly one of the ones that should compete with the Fisher and the Reliance for the title of first skeleton structure. This building was designed by William Le Baron Genet, so the same architect of the famous home insurance building that we saw was not quite the first skyscraper that is often claimed to be. But you can see here, for our purposes, how the facade is highly decorated, although Genet had demonstrated an ability to also make good use of envelopes that were quite austere, particularly in the shopfront systems of the commercial centers, like the later building, for example. But here, in a commercial building, is doing some sort of giving way to the decoration, and you can see this sort of demons here on the underside of the bow window looking down on the footpath, almost as if to somehow inspire awe and terror to the pedestrians who might look up to observe the towering height of this building. Certainly a towering building for those days, not so much anymore. Now, what is interesting for us here, apart from the obvious cultural implications of this and historical importance, obviously, of the aesthetics of building, what is really important really for a construction and technology point of view is that this technique of terracotta was there to have a double function. Yes, one function was certainly to clad buildings and convey this ornament and this sort of decor that was suitable for the times. But there was another purpose. Terracotta was a material that was becoming more and more popular because it was a more economic way to clad buildings that could allow repetitional element on a mass scale. Now, when we say about mass production or industrial production, we must not confuse the term with the idea that mass production is standardized elements for buildings that are repeated all the time. It's not an off-the-shelf approach, but you can clearly see the workers here in a architectural terracotta factory near Chicago, where there's a skill, there's an artisan approach to decoration, but the technique allows to have a sculptor doing sculptures with clay, and then transform this into a cast of plaster. You can see here, where the molds can be repeated, that can be used to repeat elements again and again. So the amount of work done by the equivalent of a stonemason this time is put in a factory, first of all, not so much on site as we saw in the traditional construction systems from the ancient times. It's first of all the production of decoration is in a factory, and it can be repeated again and again, multiple times, with terracotta. But there's another element of terracotta and clay. Steel was introduced particularly after the Chicago fire, and there was still sort of this understanding and this willingness to protect steel buildings from fire. So terracotta and clay was also the instrument through which buildings could be made fireproof, as they used to say in those days. Today, we never say that a building is fireproof, but we say it's fire safe. It's been designed to account for a performance under fire conditions that might prevent the structure to fall down. But in those days, so the terracotta was the external ornament, but was also the complement of steel that allowed structures to be fire safe, and therefore to be tall and to be put together with more confidence and more reassurance that in case of fire the buildings will stand. So the terracotta is normally referred as the envelope material that is used in those ornamental fashions, or in more simplified versions that we'll see in around the 1920s and 1930s. But then there's another technology that is often known as the clay tile. Now, clay tiles are blocks of clay that have been burnt in a kiln. So they are bricks that have been extruded that have chambers, and you can see here an example of these bricks that somehow make these blocks lighter now, but bigger as well. So they can allow to build brick walls faster. They also have some capacity to be used in floor systems in particular, but they can be used also to fireproof steel columns, for example, or have partition walls inside buildings that are fire resistant. Now, some of these systems of clay tile became very important, particularly in the construction of floor systems of steel. So we're now looking at not necessarily the primary structure of these skeleton buildings, but more at the infill floors, the horizontal structures of these multi-story constructions. And so after the Chicago fire in particular, a number of patents started to be produced for these methods of construction that were so-called fireproof. And this is even before the skeleton structure became more complete in the way we saw with the Reliance or the Fisher building. And these systems evolved like many other things in construction. So we have here two examples where we see that one of the very first ones, there was a patent here on the left put together by Johnson and Kreischer, so a structural engineer and a brick manufacturer together. And you can see what they're trying to do here is in between two steel girts here, which could be rolled steel members. They are introducing a hollow tile that is acting like an arch. It's got this sort of oblong shape that is being cast and extruded, and it's tied perfectly with the lower flanges of the two beams around. Then it's also shaped to receive some sleepers or battens, as we say here in Australia, to then receive a wooden floor on top. And on the underside so this would act like a fireproof flooring system, because terracotta and clay tile is fireproof in the sense that it's not combustible, and it does protect steel. It prolongs its duration, its lasting capacity in case of fire. But you can see the problems of a system like this that is forcing the beams to be too close, or potentially probably put too much strain on the tile itself, on the so-called the arch tile. Some systems that evolved later on, these ones from Kreischer, one of the two initial inventors of a system on the left, who went on his own. And in this case, Kreischer, what he did, he broke up this arch into three elements. So you have two side elements that engage with the beams, and then a key element that is keeping the two pieces together, but it's also acting like a flat arch. So a flat arch, if you recall, is an arch that is not quite an arch. Is a flat lintel structure, but it's using some of the same principles of an arch by having all the bricks or sometimes masonry voussoirs to be cut in such a way that their shape can push sideways the thrust. So in this case here, you have a central piece that is pushing down, but because it's trapezoidal, is transferring some of these lateral forces onto this almost triangular pieces that eventually transfer back onto the beams on the side. Now, this is the basic principle, the flat arch of terracotta or clay tiles. And the system was obviously developed further, almost in the same period, very quickly, once it was realized that there was a need to have a more practical approach. So instead of having larger pieces all to put together, suddenly these blocks became smaller and smaller. You can see one version here at the top where you have a series of skewed blocks that are engaging one each other. You have a central piece, and you have some other pieces that have been shaped specifically to combine and house themselves and protect the lower part of a steel beam. And then on top of this flat arch, there is a topping of concrete with cinder, so a volcanic rock that makes the mix much lighter. And on top of that, there's also a tie rod that spans in between the beams to somehow protect and put some and prevent this floor to fall down. Another system that uses the very same principle is the one below. This one designed by Johnson, one of the initial inventors of these flat tile arches. And you can see here instead you have a system of blocks with a circular hollow in between. But the principle is the same. They're acting like a flat arch or a plate band, and they're transferring all the lateral loads onto the beams on the side. The system eventually became almost standardized in a sense, or became accepted throughout from patents onto several buildings and several systems by different manufacturers. But the ones that really took off were these ones, these two, which you see here at the top, one which is known as the side construction flat tile arch, which is a series of clay tiles. Again, you can recognize here the shapes of these skewed elements, each one of which has a series of chambers, typically 4. These skewed elements are all the same, they go in 2 directions, and then there's one in the middle that becomes the key and changes direction from one side to the other of the floor. And then there's a third piece, which is this one, that is the end piece that engages with the steel beams. And there is a soffit tile as well that is being used there to complete the system, so that it's absolute all-round protection using clay to protect steel. Then, of course, like in the other examples we saw before, we see a concrete slab here that very often we cinder as aggregates too. So it's a lightweight concrete topping that completes the floor and that distributes the load evenly onto this flat tile arch. Now, this is the so-called end construction or side construction, which basically means that the stiffeners or the ribs of each one of the clay tiles are running parallel or in the same direction of the beams. Another system instead is still using the same material, so clay tiles, but with the ribs running perpendicular to the direction of the floor beams. So you can see here the 2 beams spaced about 6 feet apart, right? So about 1 meter and a bit, and almost 2 meters, 1.8 meters. And again, you can recognize that the shapes of the blocks or clay tiles are very much like in the other system. However, the stiffeners or the ribs inside the flat tiles are not visible here because they're running in the other direction. But you can see again how the end piece is engaging. In this case, it's wrapping around also the underside of the beam in one piece, and sometimes there is another piece here that has been inserted as well. So we have 2 systems, but then there's another third system that became almost as popular, and you can see here the so-called combination system, where you have two examples here somehow working together. The central piece is running on a way that is parallel to the beams, and then you have a number of blocks here that are running with the stiffness perpendicular to the steel beams. And you can see here the piece that will complete the system by protecting the underside, the lower flange of the steel beam. This is another variant of the same from a company known as Natco, a company based in Pittsburgh, so to show that this is a very much a North American system that's spread out through America and also elsewhere, and still carries on in some countries in Europe in particular today. And you can see here in this other version you have a number of blocks, and then you have these final pieces that are sort of running parallel to the beams. And how were these systems mounted? Well, there was a quite a clever approach that, of course, first the steel will be in place, like all the skeleton system will come up first, and then a number of joists will be run perpendicular to, so you can see the steel beams running first in these positions. There's 3 of them, and then you have a number of 2 pairs of joists running from end to end continuously over another beam in the middle, and then we have a series of bolts that are used to support scaffold, or almost of something that is more similar really to a decking for concrete, although in this case it's used to receive these clay tile blocks while it's still getting built. You can see a nice section below here that explains the process, where you have steel beams first, then these sort of joists on top, and these hanging rods from which a platform is suspended. You can see how some of the clay tile pieces that will complete the system are inserted first, and then there's another pair of ceiling buttons that are used to support this platform. So it's a suspended centering system, that's how it was called. It's really a decking system that allows workers to work in between the beams, walk safely on them. So you can see here the beams, and you can see here in the background some of these timber beams that have been put to run temporarily over the steel beams. This is a steel beam here, and this is some of the structure that is used to support temporarily this platform that can also be reused. And you can see here nicely in the section how you have this end combination system where you have all the clay tile blocks running with a stiffening chambers perpendicular to the beams. You have some completion pieces that protect the underside of the beam, and you can see this worker here completing the tile arch here with the central block in the middle. And you can see here other workers that are preparing the blocks by putting some mortar in it. So mortar eventually will dry out, and therefore this flooring system, once the mortar is set, will be able to support itself, after which the centering system is removed and the work can continue somewhere else in another bay of the floor. Or it can be also be dismantled and then taken up to the next floor using the lifts or using the cranes, and the construction can continue also vertically. Now, this takes place between the late 1800s, but it does continue for a good period of time. These techniques, the skeleton frame, the terracotta tiling system, the clay tile fireproofing methods, become the ABC of multi-story construction in North America. And beyond North America, they also become very influential, particularly in Australia. And they do so in many different ways. They do so from a technical point of view, but as we will see, they also do it from an aesthetic point of view. We always showed Chicago because that's where, it's always good to probably focus on a city in particular. So there are some, there's more ease in trying to find out connections from one building to another, etc. But this building that you probably are familiar with, the Chicago Tribune, was in effect designed by New York architects. And so, by all means, the system we saw now are somehow at least widespread throughout North America, but they also did in Europe and in Australia. Now, the Chicago Tribune is a building that is very famous, was the object of a competition. It was mostly famous in architectural history for a missed opportunity to build a truly modern building for those days. We're looking at 1920s. Out of the many entries that were proposed, some buildings became iconic for not being built because they were truly at the avant-garde of architecture at the time. But the Chicago Tribune is still a monument in Chicago. At the moment, it's getting refurbished into apartments, believe it or not. It was the headquarters of the local newspaper, the Chicago Tribune, and in this process of renovation now, in this transition to a new life as luxury apartments in the middle of the city, they are dismantling some of the lower parts. So when I was there in Chicago, or some time ago, I was able to observe closely or at least sneak through some of the fencing and observe the construction of the lower floors. And you can see how some of the things we spoke about before are starting to appear and make sense. You can see the steel members here with visible rivets here. So you see steel columns, you can still girth here, which is combining a flat plate and angle plate, so not necessarily a continuous rolled beam, but a composite beam that is put together using rivets, mechanical rivets, so possibly done in a factory. And you can see closely here that the cladding of the building is this sort of terracotta tiling systems, very much like you would have seen before in the Reliance building, but in this case it's finished differently. It's finished flat, and you can see it's mounted behind in front of a brick wall that in this case is just completing the facade. But the structure is a skeleton system. You can see here some of the columns coming down, and as we said, you can see again here a column, rivets, and again girders coming down horizontally. And the architectural terracotta that completed this building was often installed in using some system like this one here. This was not necessarily the one we just saw in the Chicago Tribune. This is a picture from a catalog of a company that was very at the leading edge of these technologies in Chicago in those days, the Northwestern Terracotta Company. But you can recognize here the steel profiles that we discussed before. You have two angles here connecting to a flat steel plate, and again another lower angle here that is used not only to work as a girder or as an edge beam, but is also used in this case to support a terracotta element which is shaped in this way. It also has a rib here, and it's becoming basically a reveal of a window, and it's obviously growing, and it's building up a bit of depth in the system. You can see there's an infill of bricks also. But from this edge beam, what's visible here is there is a gusset plate that is used to support another steel angle in this position. And this angle is running continuously to then support this other terracotta element that comes up. It sort of engages with the bricks, etc., etc., etc. And it's giving some molding here on the outside. At the back of this angle, there's another angle you can see here with a J-bolt. It's coming down and it's supporting a rod that is also supporting this terracotta underside or expanded lintel over the window. You can see this very nice 3D that sort of explains what we just said. You can recognize here a C channel here and an angle bracket supporting another system of support here with another channel, and you can see here clearly these J bolts that are supporting this through rod of steel that it's sort of running inside these terracotta profiles. So terracotta becomes, the cladding of the building becomes the ornament, but also becomes an element of disguise whenever it's possible, whenever the design needed the building to look even thicker or heavier than it was. So it is a way to sort of recreate the feeling of old masonry architecture that suddenly could not be done anymore because of cost reasons, but also it's a system that plugs into this skeleton construction system. It's much smaller, and very often terracotta was used somehow to make this building bigger than they were or heavier than they were, certainly adding weight on its own right and therefore needing some techniques. And so companies started to develop product catalogs in these days. They assisted architects to produce detailings, and they also assisted architects and builders by producing shop drawings. So by having companies that were manufacturing element, not in a mass production so that you could pick from a catalog, but very often producing new profiles specific for the jobs. Yes, for the residential markets, perhaps there was some standardized production that would repeat itself, but very often these larger commercial buildings had an element of bespoke design that was in the hands of the architects, and architects, builders, and manufacturers work together to put together this building as one-off projects. So you can see here some projects, for example, completed by the Northwestern Terracotta Company in Chicago, and you can see a catalog here from the same company. And these are the buildings that you see, or two anyway, or some of the buildings completed in those days. You can see how the towers have become bigger, the relatively stumpy buildings of the earlier Chicago, the heroic Chicago school, are becoming taller. They're becoming more needle towers. They are becoming also more influenced, perhaps some developments from New York. This is the Jazz Age. This is the Art Deco age. But terracotta and steel are the elements that allow these buildings to grow. This is the Moffat Tower, a very beautiful, a very slender tower that still fortunately survives in Chicago, or the Carbon and Carbon, so a corporate tower in this case, again using this block and then a tower on top that you can see here decorated also with gilt and also using terracotta throughout its facade, in this case with this sort of olive green darker tone. This is a building designed by the sons of Burnham, the same architect of the Reliance and so many other important buildings of the Chicago School. So all this somehow to introduce to what happens here in Australia in the early 1900s. Chicago was very important, so was New York, so was San Francisco perhaps, but certainly there is evidence of connections, and if there's also factual crossovers of people that could be documented, but from our point of view here, it will be important to see some examples that contextualize how these techniques became Australia. Now, Australia wasn't just about connections with America, but Australia had obvious links also with the United Kingdom. But one of the things that really brought steel in Australia and the steel skeleton became really apparent and compelling, because Australia, being where it is, relied very much on naval connections and with the rest of the world. And so very often some of the first examples of the appreciation importance of steel came in particular through the construction of ships. Ships that were very often built in UK, in Scotland in particular, but certainly ships that also brought over this idea of the potential of steel to Australia. And you can see here one of the ships being under construction, an Australian Orient liner. So ships built in UK for Australia, that they will become part of the Australian culture and technical expertise by adoption. And you can see, in fact, this ship is being portrayed in a building magazine, and you can see the techniques here clearly of the skeleton system that are starting to take shape. You can see riveted steel, you can see temporary blocks of timber supporting steel as well, but you can see how this carpentry of metal is the fundamental instrument through which steel becomes important. So on this basis, Australia starts to produce steel in the early 1900s. One of the first, if not the first, blast furnace was in New South Wales at Lithgow. And a blast furnace was a furnace that was able to use the Bessemer process of steel making, which control carbon or first eliminated carbon out of the melting of iron, and then reintroduced it later in the right dosages to obtain steel rather than cast iron, for example. And steel becomes also then, once produced in Australia, it gives the opportunity for steel fabricator to prosper and become also instruments of development of this technique. So steel will be produced typically by the steel manufacturers, but then there was still an enormous amount of fabrication involved in putting together very simple profiles, normally in the form of I-beams or angles, and using these profiles to cut them and then to build composite sections as we saw. So cutting was using obviously shearing machines. So suddenly you see how the factory becomes the place where you produce construction elements on a massive scale. But also the factory is the place where you're able to rivet, for example, angles onto flat bars to produce girders, like you can see here, using riveting machines that are hydraulically operated, in this case held from an overhead crane. And you can see the rivet here. There will be a furnace behind it where the hot rivets is fed through these holes, and then this rivet machine is used to rather than punching the rivets by hand, it's used to go faster and to produce also more consistent quality. And so steel manufacturing becomes Australian, but also the steel fabrication becomes very important. And you can see some advertising here of the early 1900s, how they're reproducing. In this case, this is a manufacturer based in Ultimo, New South Wales, so Sydney very much. And you can see how there's promotions saying we do structural steel work, and we take regular sizes, but we fabricate them for you. We put together the elements that they become steel and columns. So unlike today, where we have standardized systems, where we have very often a universal column, which is one rolled piece, or a universal beam again, which is one rolled piece, in the past the fabrication was more important. Very often these beams were not sufficient to create girders of a certain type. This still happens today in the steel industry. Steel industry is not just standard products, it's very much a lot of fabrication involved. And the sources of this knowledge were not just obviously American, but they're also, you can see here how there's a reference to Dorman, which was a manufacturer from England instead, who also had a manufacturing capacity based in Melbourne, for example. And obviously that still becomes also the vehicle for bridge construction. You can see here an example in the early 1900s in Queensland or Rockhampton, where the Alexandra Bridge, where you can recognize some of the profiles we saw before. You see steel beams here or girders that have been put together by using rivets throughout. And eventually, during the 1920s in particular, or late 20s, we start to see finally also steel manufacturers and miners, like the Barocking Hill Proprietary Company, also known as BHP, that start to not only mine iron ore, but also produce steel and then become a supplier, manufacturer, and fabricator of steel. So the generation of steel knowledge then starts to almost immediately at the beginning of the 1900s to become really the way in which Australia starts to build. But Australia will never build as much as America did in terms of height, because building regulations in Australia remained much more conservative, at least until World War II. And they remain conservative because of fire. The perception that fires could be catastrophic for good reason. And so you see some of the first examples that mitigate immediately, almost from the beginning, and introduce steel and terracotta or clay system, or terracotta lumber as it was known in Australia, that are used as the inevitable combination in skeleton construction. So you can see here this advertising from a company known as Liverpool Brickworks, advertising terracotta lumber. You can read how they're trying to promote it by saying, well, it's an unquestioning solution because it's been burnt. It's been burnt in its making. So terracotta has been already burnt; it will not burn in case of fire. And this is a building we'll come back in a second to describe, and that was somehow significant of the adoption of steel and terracotta for the first time. So terracotta lumber in Australia was used sometimes also in the system we saw before in America for flat tile arches, but very often also in very straightforward way to build fireproof walls. You can see here the blocks of clay tiles, as the American called them, used here as a subdividing partition that is fireproof. But also terracotta becomes the architectural terracotta, and that it was popular as we saw. It was characteristic that sort of accompanied the acceptance and the evolution of multi-story construction in America, Chicago, and in New York and elsewhere. And so terracotta becomes also an architectural instrument to conceal the steel structure. You can see a very compelling image here where there are some steel beams going up, obviously using the methods of fabrication we said before with rivets, and you can see these neoclassical columns coming to cover them behind. So very often there's this disguise of this lightness, and you can see how it's advertised here by the company Wunderlich, very successful company here in Australia. The economy of repetition in terracotta ornament. So you have to imagine this is the time where stonemasons were still around. So suddenly you had this opportunity to achieve ornament at a much more convenient way, rather than employing stonemasons and carving the rock and working it out and relying on the skill. Terracotta is repetitive. It can be that you need one sculptor to get it right for one time, then you're able to repeat it many times. And so they did. So for example, Wunderlich in the first part of the 1900s started to a company that was set up to do also other building systems, particularly ceiling systems that also had metal works. Wunderlich adopts and embraces this production of architectural terracotta, becoming one of the most therefore an important manufacturer of building products in Australia. Incidentally, the Wunderlich company had a very long-standing relationship with the Faculty of Architecture and Building and Planning in Melbourne, at Melbourne University for many years. They were one of the major major donors for the faculty for many years. For those who were around a while ago to see the older building of our faculty, there used to be a Wunderlich theatre. That was basically the largest theatre of the faculty, because it was funded, was furnished by using funds from Wunderlich. So Wunderlich basically transforms and transports also from some of these ideas from overseas into the construction systems for Australia. In particular, in architectural terracotta, it will allow Australian architects and builders to become a bit more American in a sense. So you can see here some pictures from a catalogue from Wunderlich from the 1920s, late 1920s, that celebrated 40 years of the growth of the company, at which point the terracotta was really booming. And so you can see how there's a bit of a process here. You can see the factory where you have terracotta here. You can see the kilns here. You can see the clay that is being laid out to the elements to weather. And then the clay would be normally be mixed with what's called as grog, which is basically burnt earthenware, to get the right mix to then add water to it and transform it to a consistency that can be worked. In parallel with that, Wunderlich would have a technical department that was able to produce shop drawings, so take architects' drawings, look at the design intent, we would say, and then produce shop drawings exactly like you would do today with facades and many other trades, where the manufacturer, the subcontractors take on board the design, but they are the ones who document and develop the details for production, but also are able to have an input in the detailing so that you can understand how to put things together. So once the design is taken on board, then some typical molds are prepared, molds of plaster. The sculptures usually create clay models for the first time, and then a plaster mold of that initial model is created. And it is used to press down on fresh clay several times. Usually a mold would last for certainly more than once, but at some point might have to be repeated together. Then after the fresh clay is pressed or molded into the final product, there will be sometimes a stage of retouching to bring some more consistency or eliminate imperfection of the molding process. After that, the products of terracotta will be glazed so that they can be enameled, basically to have a long-lasting finish, that it does not expose the material to freeze and thaw or collection of dirt, etc. Or also absorption of moisture that then can create further problems down the track. And then eventually, depending on the weather conditions, these glazed terracotta elements would be dried quicker or let dry naturally for a certain period of time. After all this, they're put in the kiln and they are baked, so to speak, until they become hard. And the baking process can be several days usually. So after this, then the products are created, sometimes to cater for mass production. You can see here all the kilns in the background that are sort of housing terracotta profiles, and then all the parts are put together. So there is an element of mass customization in a sense that you can customize element using repetitive methods of construction specifically for a project, but there is also mass production, so standard off-the-shelf things that can be taken from a catalog and supplied, for example, for the residential market. So now all this could influence certainly, now you have an understanding of why we have a certain transition, particularly at the birth of modernity. And I'll stress that it's important to understand this as a continuous process. So we find that, for example, in Australia, in the late 1800s, there was already a bit of a fertile ground for the development of techniques that induced developers or landowners to build multiple floors above a block of land. This became most apparent in Melbourne after the gold rush, during which time Melbourne managed to build a remarkable office commercial tower known as the Australia Building. You can see here in this beautiful picture, but unfortunately the building does not survive, believe it or not. This was demolished in the early 1980s for something that I couldn't even tell you what it is today. Something certainly not as valuable as this, but you can see this view here of Melbourne. You can see Collins Street and running there, and Elizabeth Street, and you can see there's a towering building there coming out. Well, that was the Australian Building. That is gone. Now, the Australian Building wasn't a Chicago school building. It was a masonry structure like this other wonderful building that we lost in at the corner again of Elizabeth and Collins. Not far, in fact, from the Australian Building. The Colonial Mutual Building, also initially known as the Equitable Building, designed by an American architect, but not very much American, but more of a masonry structure. So this is the generation of taller buildings, perhaps, that were more pre-Chicago School Revolution times, and you can see how masonry is the dominant material. When you're looking at this building, they're not very tall. They don't necessarily have many floors either. But during the earlier part of the 1900s, suddenly Australia starts to adopt steel. The steel that came through naval architecture, bridge construction, and then the terracotta that allows steel to be protected. But often in a hybrid fashion, like you can see here, you can a warehouse building here on the right, and a show-off picture here to show a plumbing system in a multi-story building in Sydney, where you see clearly steel framing going up and connecting onto a brick wall. And you can see this warehouse here under construction in Pitt Street, where you have brick walls on the side and steel framing in between. And you can even, if you look closely there, start to see some of the floors being put together that seem to be like clay tar blocks in that position. And then you start to see buildings that commence, we're talking about 1907, 1908, 1910, they commence to use steel as the dominant structural material. One of the very first, certainly, at least that was publicized in Journal Building, which a journal for architecture and construction. It was very important and popular in the early 1900s in Australia. A journal that was mostly in Sydney, published in Sydney, but they had a reporter in London and a reporter in Chicago, and so you can see how the influences from America start and from UK at the same time start to come to Australia. And one of the first buildings that was publicized in building during the early 1900s was this, the Commercial Travellers Club, which in its first version was somehow mimicking, in my view, some of the old colony buildings. You can see the corner there with a round bow window. You can see a very timid bow window there in the middle. You can see a base of Romanesque stone masonry, and then the repetitive floors going up. Now this is the Commercial Travellers Club building as finished. The corner bow window has been removed. The Romanesque base has remained. And a bit of bow windows have remained too. But you don't see so much from this picture. It's stone clad, but the entire skeleton was made of steel. There's this interesting picture here. You can see steel columns here. This is the edge of the building. And you can see here the slab that was built there was actually a concrete slab, not necessarily clay tar slab. And the building was quite remarkable because it came up only in 5 months. But the way it was built, however, you can see some steel work. You can see this remarkable tower crane that has been set up here. This is a derrick type of crane that is movable, sort of anticipating, the cranes of these days too. But you can see how the frame is going up in steel, but the masonry is following almost at the same time. So there's no steel skeleton sort of jumping before anything else like you will see instead in Chicago. But nonetheless, a series of buildings start to be produced in these years. We're talking about the 1910s, particularly in Sydney. These are 3 examples designed just by one architect firm, Inskip and Rosenthal. Until around the 1920s, finally you start to see this very confident steel construction applied in a department store here in Sydney, for example, the Goings Brothers building, where you can see clearly now you just have steel goes out first, and then the rest of the cladding will follow at a later time. And you can see buildings that start to also pick up some of the ideas from American architectural terms. This is the Grace Brothers department store in Sydney. You can recognize obviously some obvious affinities there with the Chicago Tribune building. And you can see in plan how this is a skeleton building all around. It's got a light well in the middle. It has a core here at the back, with elevators, some for the public and some for service. It has a ring of space. It has freestanding columns all around on the perimeter and inside the floor plate. And it has a architectural terracotta facade provided by Wunderlich. So you can see these beautiful drawings here that are exactly like you should do a facade drawing. Still to that, you have a portion of the facade here in terracotta that has been clearly, very well drawn. You see the windows, you see what's the piers that come out. Then you see a plan here below of the same portion of the building, a corner of the building. And then you can see a nice section where you can finally recognize the steel members and all this terracotta ornament that it's supported from them. And here you can see the details of the tower. You can see the sort of a bit of a timid, certainly much shorter and much stampier version of a Chicago Tribune, but certainly the neo-Gothic reference to that famous building is most obvious. And the reference is so obvious that you would have recognized that we have almost a very similar version of that in Melbourne, which is of course the Manchester Unity. A building a bit more daring than Sydney when it comes about height, but again reminiscent of the Chicago Tribune, particularly in the treatment of the corner tower with this sort of flying buttresses and neo-Gothic Art Deco style of the time. But more importantly, the Manchester Unity is another example of steel frame construction and terracotta, and using the Wunderlich products, in fact, that the company, in fact, didn't miss to advertise the fact that they were supplying terracotta for this new landmark for the city of Melbourne. You can see the similarities here with the building in Sydney, the Grace Brothers department store, but because you can see, because they're sharing the same techniques, they are also sharing the same manufacturer of the facade. There are some differences for the Manchester Unity, which is fireproof, also using concrete, but certainly it is still a skeleton building, and you can see the emphasis here clearly on the fastness of the construction system. So from May the 16th, first floor, until July the 29th, in a matter of months, the building is done. And another important thing on Manchester Unity is the first building to have an elevator, for example, an escalator. Sorry, of course, the elevators or lifts were already common in Melbourne at the time. So these are electric buildings. It's time where we reach now at the interwar period between World War I and World War II. But these are the techniques that really characterize those years, and they are the techniques that set up the conditions then for multi-story construction, and for many aspects of modernity also to take different shapes later on. But the technologies very much are the same that we already discovered in Chicago in the late 1800s. So I'll conclude here, and hopefully you enjoy this, and if you have a chance, when you can, go and have a look at the Manchester Unity in Swanston Street whenever you're able to do so.